So, as we have today a contribution day related to Magenta, I would like to talk about a little bit about Magenta, but not only about Magenta. Actually, it was started like a Magenta, and today I'm going to talk about how to time Magenta static test beast. But first, let me introduce myself. My name is Oleksandr Kravchuk. I'm working as backend developer at Waymo, United Arab Emirates. I'm certified Magento developer, contributor, maintainer, and Magento Master 2020. And I understand that even Magento Master write a bad code. And today I would like to talk a little what you can do to avoid situations like this. And the best core for this is, of course, to write tests. And let's play a little. I will show schematically the chart flow of test, and you need to guess which kind of test I'm trying to describe. Any suggestions? Okay, it's a unit test, so you receive some information as an input to your test, you interact with some isolated part of the code, and in result you compare results of your execution of the code and with your expected result. And a little bit more complex.
Integration
test. My options to the chat, so just do not spam everyone.
Okay, please talk because I have like open a screen with the presentation and cannot see the chat. Yeah. Yes, exactly.
Integration. Yeah.
Yes, you are right. This is integration test. So to our isolated part of the code, we add all other code of the system, or all other parts of the code system, and of course there can be added some different resources like a database in this example. And this?
Functional testing?
Yeah. Yes, you are right. So in this case you have like two different applications. First one is busy to write the test, and second one is busy to execute the actual functionality, the behavior. And here we have like a separation between these two parts. Actually, it can be like one code base, but it still communicates with some middle environment. In our case, it can be like HTTP protocol. So when you write MFTF tests, you use browser emulator to make calls to your Magento with HTTP, and the same when you write functional tests to test API, you make calls with a curl client. And this one?
It sounds like static analysis.
Yes, you are right. This is a static analysis. So as input, we receive not information, but the code. Our tests have some rules, and the result is check if code is matching the rules. And I think the most brilliant thing that in case of static tests, you need to fix the code, but not like write a new tests, usually. And if we can check what kind of static tests have Magento, we can separate like 4 different groups. First one is live code tests, which I'll talk a little bit later. Second one is JSTS, which actually call Jasmine, which executes all static checks for the JavaScript. And there's a group of integrity tests, which make some sanity checks of your application and check that everything is okay. For example, that you have declared all required dependencies in your model, and etc. And legacy tests, which avoid you from mistakes of the past. And if we look deeper in the live code tests group, there are 4 subgroups: GraphQL, PHP, Less, and HTML. Most of them are just calling code sniffer for files with certain extension. The PHP group has 6 subgroups which call different tools to make some checks in the PHP. But if we look for compatibility, strict types, and copy paste, it's pretty easy how it works. But for code style, code method, static analysis, it's become more interesting. In this case, static analysis, I mean the testing of the code with the static analyzer. So, because actually it's everything about static analysis. And let's start from the code style check. Assume that we have some code, and the first thing which I try to do when I receive some code to check it, or to make a code review, I try to read it. For human beings, it's pretty easy to read some text, but if we start to think how to optimize it and make this check automatically, it's become a little bit tricky, because we can read in different way. We can read by symbol, or we can read word by word, separate them with spaces, and etc. Fortunately, we can use specific thing which use PHP, not just any interpreter. Before it starts to execute the code, it's read it and interpret it with tokens, tokenize it. And fortunately, we are working with the best programming language in the world, with the PHP, and it's pretty easy to receive the list of this tokenized list of tokens, which before it will be executed. So if you say PHP, please provide me tokens for this part of code, you will receive the picture like this. And from this, we can simply understand that it's really difficult to understand anything from this. But for PHP code sniffer, it will say that you violated PSR2 rule and you forget to mention the new line at the end of the file. And the most interesting thing that in such case we are working with regularity. We know that, for example, in our code, if we have a function declaration, that there should be a white space. After white space, there should be a name of the function, but in some cases there can be no name because it can be an anonymous function, and then there can be type declaration, or there cannot be. If we have a type declaration, then it must be a white space and must be a variable, or there can be any variables. So this information is pretty enough to make testing works, except if you would like to check that this code is full of some coding standards. If every new line is placed correctly, that every space is placed correctly, and etc. But what's the problem with this check? That it provides only how code looks like, without any understanding of the real meaning of this code. It's like I don't know, if someone asked me to read Chinese, I can see this hieroglyphs, but I do not understand anything. And to try to reach some meaning of what is written here, there are really tricky things that exist. And one of the things has name abstract syntax tree. So one of the way to show that to extract some meaning from the code. So how it works? It works the same as it works with the tokenizer. It's reach the tokens from the code, and then it's build a syntax tree. But before this, let's come back to our example. What we can see here, we have on the top level, we have two two things to do. First one is to declare a function, and second one is to call this function with the echo. When inside the function we have if statement with its own condition and statement which will be executed. This if also have else if with its condition and statement, and have else with its statement. And if we build the abstract syntax tree for this, we will see a picture like this. So actually totally the same. On the top level we have, like from the root, we have two subnodes. First one is the function declaration, second one is the echo with the function call and the argument which being passed. This function declaration we have we have subnode with parameters and subnode with the statements which include this function. And the statement we have only one, it's a if, with this condition and statement which being executed in the case of if condition is passed. And we have else if with its condition and statement, and also we have else with its own condition. Most interesting thing that in case of abstract syntax tree, all your leaves will be some scalar values or just variables. And this is pretty enough to have some not only like view of the code, but also to have some meaning of the code. Because, for example, if you can find some node which is related to the class, you can calculate the number of dependencies which this class has, or you can check the deeps of some separated nodes to check the npath complexity. And this is actually with which PHP Mess Detector works. It builds the abstract syntax tree with the pedefense library and use PHP reflection to collect different metrics and check if your code is good enough to meet this metrics or not. And there also is an alternative library which called PHP Parser, which wrote by Nikita Popov. It provides possibility not only to build abstract syntax tree, but also create a visitor which can traverse this tree. And the visitor has two different events. First one is enter the node. It's, for example, when you meet any node, you will enter the node will be event called. And after you will reach all child of this node and will leave from this node to its parent, there will be called event leave node. And for example, how it can be used? It can be used to, first of all, is to read the tree and collect different metrics. And second way is it can be used to modify the tree. For example, if we have task to check our code and remove all our dumps, which someone just debugged the code and wrote few var dumps and forget it. We would like to avoid such situations. We can create a visitor which will run across the builded tree, and we'll check if it has any nodes which are expression as a function and the function name is vardump. He will call the event to remove this node. In result, we will receive abstract syntax tree without the vardump nodes, and we can make transformation back from the tree to the code and write it, and voila, we refactored this code with automatic rules. And probably someone can think that it's a really good idea to create some automatization in this case and provide some framework to simply write rules and actions which need to be done in some cases, and do the refactoring of some routine things are automated and easy. And unfortunately, this tool already exists. It has name PHP Director. It's a code reconstructor tool which uses abstract syntax tree and static analysis to modify and refactor code according to the specific rules which you can specify. The most interesting thing which I heard about this tool, it was a presentation of one guy, actually I don't remember the name, the last year in the Kyiv, the PHP FW Days conference. He shared the case when they used this tool to refactor, actually not refactor, to migrate from native framework to Symfony. And there is the size of changes which were done. And they spent like 100 hours it was really surprising for me because 100 hours for me it's not enough to migrate, not migrate, to upgrade Magento from 2.2 to 2.3, but it's a really interesting case. I don't know should we believe it or not, but in any way we have a tool which can automatically refactor the code. And finally, about static analysis. I mean, run analysis with static analyzers. So how it works? First of all, we need to load codebase, and then we need to build the tokens from this codebase. We can use a PHP tokenizer here, and then we need to build abstract syntax tree. We can use the PHP parser library, and then we can analyze this abstract syntax tree with for static analyzer and receive results of this analysis. And what static analyzer can do? He can check PHP syntax, just that syntax is okay, anyone don't miss the semicolon. It also can check that all methods, variables, functions, classes, and constants which you used they exist. And it also can check that PHP and docs are up to date in your code. And the most powerful and brilliant things of the static analyzers and the static analysis at all is that it can make checks with the type in which you write. So, for example, that if your function is expecting to receive the argument string, first argument is string, it will check that all places where your function is being called, the string is passed. And vice versa, when your function is expected to return Boolean value, it will check that in any return you have in your function will return the Boolean value. Actually, this is the most thing which differ the static analyzers from the PHP mess detector. About static analyzers, what have in open source? There are 3 on this market, not market, open source. Pan, which was started by Rasmus Lerdorf, one of the founders of PHP. Psalm, which was started by company Vimeo, and PHP Stan, which was started by guys from Czech. And what about Magenta? I guess that the most reason of which static analyzer was chosen by Magenta was the abusing of usage of magic methods, because the most important thing for static analysis is to have strict types, but not only strict, just types declared. It can be not only strict types in the code, it can be types in the docs. But in case of using magic methods, it's really difficult to check it and to follow it. And in result, it makes the static analysis not so helpful. And actually, the PHP Stan is the only static analyzer which can work with these magic methods. So the selection was obvious. And one of the advantages of PHP Stan that it can run not the check for the whole codebase, but run the check for the some specific files. In this case, Pan static analyzer is to be like an orthodox static analyzer, because it just read the whole files in your project. It's built the giant abstract syntax tree and started to analyze the whole tree, and we can just imagine which terrible things we can find there. Which terrible things can be found there. And it do not interact with your code directly. It only read your code like some just a text. But PHP Stan can interact with your code in case when it's run for just few files, it can find, I don't know, some references for another classes which it doesn't know. And in result, it will use your afterload file to load this file and interact with them to make the analysis complete without just showing the error that you're using some not existing class. Very smart in this case. And the really easy API not easy, just wide API and easy to extend API and add your own rules for your own checks. And actually is how to run Magenta static tests. Probably after this contribution, I think most of us will know this. And there's a little bit about this configuration file. So you can, for example, it can be useful not for contributing to Magento, because when you contribute to Magento, all configurations are required to follow, because GitHub will not pass your pull request. But actually, if you would like to use a static test on your project, on a commercial project, you can edit this file and run only some of them, which can be really useful for you. At least I think that live code tests are really useful for any project. And it's it. Thank you for your attention. Probably you have any questions.
Yes, thank you, Alex. Yeah, we got a question. It was from one member. So he is asking, how long would it take to migrate projects from Symfony to Magento 2 with this tool?
Actually, this is a good question, because this is a good question because it really depends. It really depends on the level of customizations and etc. In the case of this migration from native to Symfony, they searching not for code to migrate, they searching for the patterns to migrate. For example, they had more than 100 different roles which they use as the API, and the only thing they need to do is to migrate some framework stuff, like my class blah 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 extends class blah 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 to, and you need just to switch this extendance and probably change some arguments which being passed to the computer to the constructor. And I think it really depends. Probably there can be some examples of guys who try it.
Yeah, probably if you can consult Igor Minailo on this, he will be happy. This question was from him. Okay.
Oh, okay.
Thank you, Oleksandr. Thank you so much.